Can you hear me now? Okay, great. Okay, welcome back, everyone. We are now transitioning from our discussion of screen scraping to our discussion of application programming interfaces. And we're now up for a really long chunk that's going to go for almost an hour and a half. And so these times on the schedule may not be perfectly precise. So if you're following along again, the annotated code, the markdown files with all the notes are here, and the slides are here. So I'm going to go ahead and open up the slides. And I also want to mention, if you have questions throughout, I don't have any slides that say questions, but I will periodically pause and ask for questions when we get to the end of a section. And that goes for those of you following on the live stream as well. Feel free to Slack messages to me, and I'll try to handle them in between sections. Okay. So we just went over screen scraping. We learned that it's very often illegal, very often frustrating, and very often difficult to do. And quite fortunately, an alternative has emerged in the past decade or so, known as the application programming interface. And these are going to be things that become really an essential tool in the computational social scientists toolkit. So what is an application programming interface? It's a little strange to think of yourself as an app developer, but that's what we're going to have to do to understand how an application programming interface works. Essentially, these are ways of making custom requests for information from some type of data repository online. So for example, we might make an API call to get the list of Twitter followers for Matt or Duncan or something like that, right? And then we can specify a given user, we can specify the type of data that we want, and we get back a very neat and square data frame that doesn't have any of the HTML or HTML tags that were so frustrating to work with in the case of screen scraping. Let's take a moment to just discuss briefly kind of the history of APIs and how they came about, because it'll kind of tie into some of the ethical issues that we've been discussing. So, really, APIs, they're not just about collecting data for research. And again, this is getting back to our ready-made versus custom-made data analogy that Matt uses in the book bit by bit. These are really ways of linking different websites, different repositories of information. And so app developers might very often say, build an app that allows a Facebook user to share a New York Times article with their friends or something like that, right? And in that scenario, what we'd actually be seeing is an app or a piece of software making requests for data from, say, the New York Times, say the name of a link or something like that, and then sending that data to Facebook's API to then include it in some type of, say, suggestion app, like you might like this article or something like that, right? Why did this come about? So earlier I mentioned, when we were talking about screen scraping, that we used to kind of live in the wild, wild west. Right? Anybody could get most data, right? Because most sites weren't aware of the danger of letting their data out into the wild. And in fact, many sites, earlier I asked if who knows MySpace, American Online, does that mean anything to anybody? AOL was once the largest internet browser or search company. And they did something that they thought would be great for researchers. They released a corpus of search terms that a huge group of people had searched for. And the idea was that this would have some enormous benefit for research, right? That you could see what people were, what types of terms co-occurred in different people's search histories. We didn't know, they didn't release the names, of course, but they released all the data. It turns out that people Google themselves, right? And often repeatedly. And as soon as you know that, you can get someone's name and everything they search for, right? Big, big problem. And that had a kind of a ripple effect across Silicon Valley many years ago that made a lot of industry very nervous, right, about issues of data privacy. And by the way, they're also worrying about distributed attacks by bots or other type of automated threats to the infrastructure of their website. But the issue of data privacy rose in prominence, right? It was really bad PR for Silicon Valley companies to be in that headline that says AOL shared hundreds of people's web histories, right? So that was bad, and there was a lot of hunkering down with the data. But then around the same time, Web 2.0 is emerging, right? And increasingly, the web it was already massively interdependent, but it becomes even more massively interdependent, right? Facebook realizes, and other companies like it, that in order to survive, it has to share its data. In order to take the New York Times reader to Facebook, the New York Times has to share data with Facebook and vice versa, right? And on and on and on to Spotify or Google Maps or whatever, any number kind of different apps that we might use, right? And so this produced a kind of renaissance, a kind of like a renewed period of data access where lots of companies opened up substantially after having closed down after the AOL scandal that I just mentioned, right? And so now, now we live in a world where there still is a lot of data on APIs, but we've had a number of more recent scandals where people have abused APIs and created massive privacy issues. And again, just tying this back into our ethics lecture from yesterday, sorry. I'm sure we'll talk about ethics tomorrow. We always talk about ethics. This really ties into that insofar as data can be programmatically collected and combined, and especially when metadata can be combined, identifying people can be possible, especially when multiple data streams are connected, right? So basically what we're going to do in the next hour and a half is work through some basic tools for working with an API. We're going to have to go over some concepts that'll be new to some of you, like obtaining credentials and rate limiting. But then we're going to get into some more perhaps exciting applications of APIs, as they're often abbreviated, specifically building apps for the purpose of social science research. And then we're also going to talk about building bots for social science research. But before we go all the way there, let's start with some basics. Here's the growth of APIs from 2006 to 2018. You may be thinking, oh, well, Facebook has an API. Google has, about 100 APIs now. Twitter has an API. But I encourage you to go check out this list of APIs. There's now nearly 20,000, I think, and counting. This website, Programmable Web, has a searchable database of APIs. And if you go there, you'll find that APIs have not only become repositories for information or data, but the APIs also exist to, for example, do analysis on your data. So you can use a facial recognition API to classify the gender and race of people in a picture that you upload to an API. You can do optical character recognition to transcribe text in a picture format into strings, right? And on and on and on. There are visualization APIs, machine learning APIs. And so really, again, even if you're not out to work with digital trace data primarily, you will probably at some point in this field need to work with an API. So how does an API work? Let's look at a simple example. We're going to make a call to the Google Maps API. We're going to give it the name of a place, and we're going to ask it for the latitude and longitude of that place. So we're geocoding a named entity here. And the way we do that is actually pretty simple. We actually construct a URL, and when we put that URL in our browser, we will see returned to us some type of data, very often a data format called JSON, sometimes XML data. And then essentially, you can think of it as then we're going to scrape that data from our browser. And so when we say making an API call, it really means that we are stitching together some type of URL. And the stitching together is the important part. As you'll see here, most APIs will have some type of base URL. Here, this one is called maps.googleapis.com. And then within that base URL, we need to specify which part of the API we want to use. Here, we're going to use something called the Geocode API. It happens to live in this maps /API /geocode. And then we're saying we want the data format we want, which here we're going to ask for, again, JSON data, JSON. And then finally, at the very end, we have a query here for Duke University, right? So what we're going to do is if you cut and paste this into your browser, you should see something like this. And what you're seeing here is JSON data. And though it may look messy, right, it's not in the neat square format that we might like, it's actually highly structured. So these brackets here, all of the fields or variables that are in quotes, if you're zooming in on the slide, if you've got them pulled up, right, help us really quickly and efficiently parse through the data. So here the data that we want are the latitude and longitude of Duke University right here, right? And so if we were to, in this hypothetical example, want to geocode a long list of places in the world, we could write a loop. And at the end of the loop, we could switch out the names of the places that we want to geocode, populate a data frame, and so on and so forth. There's a number of reasons why we wouldn't just want to write that loop and go. And we'll talk about those in just a second. But in terms of the big picture, that's what an API is, and that's a very simple example of an API call. Are there any questions so far? No? OK, great. So one of the reasons why we wouldn't just want to make a loop and say, ask Google to geocode 20,000 cities, is that after we made our 1,000th call, or maybe even earlier, Google would tell us, you're not allowed to get that data. One of the unique properties of APIs is that you need to establish some type of identity, often called credentials, that define you before the site that you're trying to make API calls to. And this allows the site to know who you are and to count the number of times you make data requests and to identify which types of data you are requesting. But it also gives the site the flexibility to allow different types of people to get different types of data. And that's going to be critical in an era where we're worried about data privacy, right? So if I go to Facebook's API, I can request a list of my friends, right? But I can't request a list of Duncan Watt's friends, right? Because he hasn't accepted my Facebook friend request. I'm really bummed. Right? So we can go to a tool like the Facebook API Explorer here. And this is kind of something like a sandbox, which is kind of like a site that we can use to play with and explore the API. And if you go there, so I'm just going to click there. And if you have a Facebook account, if you don't have a Facebook account, that's fine. You can follow along with me, except that I'm not logged in. Shoot. And I don't have my password handy. So in the interest of time, I'm not going to do that. But if we did go there, or if you were going there now, you would see at the top of the screen, again, if you're a Facebook user, at the top of the screen, you'd see a long string of text called an access token. Then you'd see another bar right here that says the fields that are being requested. And then you'd see a code output window right here where that JSON data that we just looked at in the Google case would live. And this bar in the middle of that page is allowing you to try out different queries and see what you can get. So if you put into that bar /me, you would see a list. You'd probably see your Facebook numeric ID. Not very interesting. If you wrote me /friends, you would see all of your friends, or actually I think it's now all of your friends who have installed the Facebook API. So if you have computer programmer friends, they might be on there, right? But your mom or dad might not be on there, right? OK, and then you'll see the JSON data at the bottom. And if you take a moment to kind of play around on the site, you'll find that there's a lot of fields that you can't get access to, right? There's good reasons for that, right? You're not supposed to see other people's data. But you'll also notice if you play around on the site a little bit, for example, pick your favorite Facebook fan page. Let's say, oh, it's too bad we don't have our institute, but I happen to know of a organ donation nonprofit called Donate Life, which is the largest organ donation group in the US. And if we come to their Facebook page here, I just Googled their Facebook page. At the top of the page, you'll see at the end of the URL, you may need to zoom in to see this, you'll see Donate Life. And if you put that into the query bar on the Facebook Graph API Explorer, which I unfortunately can't pull up, you'll then be able to make requests for everything you see on this page, right? Things like the About Me, or what is the purpose of this organization. You'll be able to collect all of the posts produced by the organization. You could get all their photos, all their videos. You could get all public user comments, right? So you'd have to explore around in the sandbox a little bit to figure out what the API query is. And there's a drop-down menu on the left side of that Graph API Explorer page that would allow you to play with those types of requests. But you'd be surprised. There's a lot of information you can get about this page and any other public page. Why? Because these pages have expressly allowed people to access their data, right? Unlike someone that has a private individual Facebook page, and this is, of course, the vast majority of Facebook pages. So I mostly show you this tool, or tried to show you this tool, to give you a sense of what credentials are, right? You need to define yourself in some way vis-a-vis the API so that they know what type of data you're allowed to request, and then also how much data you can request within what type of time frame. So this can be useful for the owner of an API to not only define who gets access to what, but now increasingly we're seeing the monetization of APIs. So for example, Twitter, that we can make a lot of calls, and we're about to make a lot of calls to Twitter's API, you can now pay for premium access to Twitter's API for as much as $2,500 a month and get different types of data that you can't get without paying. And so once you've paid, your credentials change or you get new credentials, and then you can make different types of calls and get different types of data. And so your credentials are really, again, your identity before the API. Okay. Going back to my slides now. That was an example with Facebook. The other issue, so earlier I mentioned if you make too many requests for data within too short a period of time, then you will get rate limited. And this means that the API is telling you, you can no longer have data. You will often see cryptic error messages. You may see OAUTH or timeout or all sorts of other language SSL error. And what these are all telling you is that the site has decided to block you from getting any more data. And typically you will have to wait for some amount of time, maybe 15 minutes, before you can start, or sometimes a day, before you can make any more calls to that API. And so it's very important to understand rate limiting, because if you write the hypothetical loop I mentioned earlier, where you're simply trying to scrape, make 10,000 calls to Google's API, right? You are going to get rate limited. Probably, I think most Google APIs allow you to make about 1,000 requests a day without having credentials. But if you make those in rapid succession, like if your R loop doesn't pause at the end using something like the sys.sleep function, then you will probably trigger rate limiting much quicker, maybe after your 40th or 50th call or something like that, right? And so the struggle with rate limiting is that it changes across sites. Right? And certain sites have, very often, the rate limits might be 1 second, but then on others they might be 10 seconds, And this is just very much site dependent. And one of the frustrations of working with APIs is that different sites have different structures of their API, so you'll have to learn each query language for each API. You'll have to learn a different credentialing process, meaning you'll have to learn different ways to register yourself as a developer in order to get credentials to access data. and then you'll have to learn the rules of each API. And so these are things that are all described in a very long document. Typically describes the API documentation. It's often a large page that describes all these things. For example, the types of things you can request from the API, how to get credentials, sometimes when you get rate limited. Sometimes APIs do not list the rate limits because if they're known, then people could easily code up to the point where you could make just enough requests before you get rate limited and then keep, and that would obviously strain the servers. Yeah, I think there's a question from the Slack.
Hamid from NYU is wondering if these APIs can extract public data and not just data that's on your friends list or something along those lines.
So I think if the question is about Facebook, then if the privacy settings of that page are public, so let's say that Duncan Watts had a public Facebook page, right? Then yes, we could go scrape Duncan's page. I'm not sure I answered the question right. If not, please follow up with me on Slack if you would. Okay, so rate limiting, credentialing, these are two things we have to understand, and they're non-trivial. So we're going to try to further illustrate these two concepts, credentialing and rate limiting, and making API calls through an extended discussion of Twitter and Twitter's API. And so if you want to follow along, or if you hope to, in the future, collect Twitter data, or say build an app that works with Twitter or a bot that works with Twitter, you would need to first register as a developer, and you need to have a Twitter account to do that. And if you don't have a Twitter account, you will have to likely put in your phone number when you sign up for Twitter. And that is so that Twitter can use kind of multi-factor authentication. That's to make sure that you are a person, right? Because you can imagine making hundreds of Twitter accounts and making hundreds of API calls, right? And so if, first of all, Twitter kind of monitors that in a variety of ways, including your IP address or the location of your computer, but also by asking you to put in your phone number when you create an account. And then it will disallow accounts that have too many phone numbers, essentially. And of course, hackers could find ways around that, but it's sufficiently annoying that it will slow people down from collecting too much data, or for example, creating bots that spread misinformation or attack people. And we'll talk a little bit about how Twitter has tried to build such regulations later. But if you've got a Twitter account, and if you went to apps.twitter.com, you would then see at the top of the screen a button that says Create New Application. And if you press that button, you'd come here. And again, this is a little funny because in this example, we are simply writing some code to try out some API calls with Twitter. We are not building an app. We are simply kind of trying to establish ourselves vis-a-vis Twitter and obtain credentials. And so if you can name your app whatever you want. You could name it, my favorite app, though that one's probably taken. You could write a brief description, test for class or test for first app. You'll see there's a website field here. The reason for that is most apps actually have a website. And on that website, they would list, for example, the privacy policy, the app's terms of service, or something like that. And so that's the main purpose for this website here. You could put in your website if you like, or really any website. And finally, there's this callback URL. And that's an important one because it allows the API to know where to send the information. So you may host an app on a different location, like on a cloud server. And this is a string of numbers that looks kind of like a URL that tells the API where to send the data that you've requested. And so in our case, we are going to use this callback URL, which is just going to tell Twitter to send it back to our browser instead of, say, a cloud machine that we may have created. And the other thing we're going to need to do, again, this is something that just changed, I think, last week, is we're going to have to uncheck a box. I'm not sure if it's still there. It was as of a few days ago, called Enable Callback Locking. As if we enable callback locking, then the R package that we're going to use to work with the Twitter API is not going to work. So make sure, if you're following along, that you've specified this callback URL and that you've unchecked Enable Callback Locking. and then also that you've given your app a name, a brief description, and a website. And here you also see you're signing a developer agreement, which is a very long legal document that describes how you're allowed to work with Twitter's API. And again, I'm not a lawyer. I can't give you legal counsel on how to do this, but I'll try to distill some of the best practices that occur in the field. And many of them are obvious. Don't abuse the API. Don't abuse rate limits. Don't build bots that do distributed attacks or spread misinformation. These are the genre of things that are, of course, of most concern. OK. So if you've successfully created your app, you could then click on this tab at the top that says Keys and Access Tokens. And there you'll see your credentials. You're not seeing mine. I wrote over mine here in this slide, where it says your code will appear here. You should see a long string of letters and numbers. If you were on the Facebook site earlier, it might look like that access token, just a long string of nonsense. And that is a code. Those are your credentials. By the way, be very careful with them. If you let them out onto the internet, if, for example, you post your code onto GitHub or another site where other people may obtain your code, and you put your credentials at the top of your code when you're starting out your code, then another person could steal your credentials. So these are things that you do not want to be spreading around the internet. And there's a variety of ways that you can store them locally on your machine. It depends on what your setup is. We could get into specifics if people are interested later. OK, so we need all these long strings. And we're going to use a package called rtweet. Remember that APIs are kind of constantly evolving. Some of them are better than others insofar as how much they change when they change. So Facebook is a little notorious. They have a huge, huge set of data, right? They have a huge set of people wanting to work with it. And they have a constantly evolving structure where there's new kinds of privacy concerns that emerge, for example, after the Cambridge Analytica controversy, right? And so it very often is the case that an API will change. Things you used to be able to get access to, you're no longer to be able to get access to. Things that you, code that you might have used that worked last year might no longer work next year, right? And this is because APIs are changing. They're living they're kind of living creatures. And maybe people are trying to standardize the query language across different domains, meaning trying to standardize the type of words you use to request different types of data, right? And so for this reason, we're in this open source world where there's lots of different modules in Python to work with Twitter. There's lots of different R packages to work with Twitter. In the R community, we used to use a package written by Pablo Barbera, the political scientist at USC, who's done a lot of great work with Twitter in this area, called TwitR. We like the R jokes, capital R jokes, TWITTE, capital R. And that has now been kind of deprecated, and the preferred package, the one that has the most support on GitHub and elsewhere, is called rtweet. Now, if you install the package here in this manner, you're installing it from CRAN, the main R archive, where all of the officially vetted packages live. And earlier I mentioned that you want to be careful when you're installing new packages to ensure that they are legitimate. The CRAN site, CRAN, does a very good job, generally speaking, of vetting packages and reviewing the code. You can also install packages, and indeed we will be installing packages from GitHub, and I'll show you code to do that later. And sometimes it's the case that when the package goes to CRAN, the official kind of vetted site, that it needs to be changed, right? So when I was just showing you that uncheck enable callback checking, right? If you were to read the documentation for the rtweet package, you wouldn't see any mention of that, right? And you might try to use it, and you might get frustrated, right? Because it takes a long time to get a package vetted, and it's a long process, many of the revisions of the code will occur on GitHub, and issues will be defined, and the developer, the owner of the code, will respond to them and tweak the code, or other people can propose changes that then that owner of the what's known as a repo or repository might change. Okay, and so sometimes we might want to use the GitHub version if we're getting the latest version of the software. On the other hand, the latest version may have bugs that haven't yet been vetted. So just be aware that there's multiple ways to work with open source software, and that GitHub very often is a great choice, but it will depend on the package and the developer, and especially the generosity of the developer, right? It turns out it's really hard to build and maintain an R package that is very usable, that anticipates all the many problems that different people might have. Think about it. You have to anticipate, well, some people might have a Windows issue, and some people may have a Mac issue, and some people may have a Java dependency or a type of software that is part of your operating system that's changing something, right? And so you have to anticipate all those things, or you have to anticipate all the different error messages that could be produced by, say, an API, and then translate them into real English, right? Saying something like, you've been rate limited. Please wait 15 minutes before making your next API call, right? That would be a lovely error message, but you don't get that message from this package. You get some nonsense about SSL errors, right? And this is a fairly good package, and the author of this package does a pretty good job of responding to issues that develop. So you're going to want to gain familiarity with GitHub because many of the newest and greatest packages or Python modules live up there, but also realize that these can be very buggy. Sometimes they can be better than the versions that are archived in the main R community CRAN. Sometimes they can be worse. It just depends, unfortunately. But R-tweet should work from CRAN. At least it did a few days ago, the last time I checked. And the first thing we need to do is define our credentials. Whatever name you gave your app needs to go here, where I've written your app name here. The consumer key, you may have noticed Twitter gives you 4 different credentials: an access token, an access secret, a consumer token. And these are all just codes that have various purposes for Twitter to specify who can use what data, right? And now we're going to take 2 of them and define them in our R session, give them an identity here, app name, consumer key, consumer secret. And then there's a function in the R-tweet package, which we need to load by writing library R-tweet. And that function is called create_token. And what that's going to do is create something that's often called a handshake it's really more of an authentication step with Twitter. And so what we're doing is in this create token step, we are passing along those credentials. We're saying, here's my consumer secret, here's my consumer key, here's my app name. And if you do this, and if it's working presently, your browser should open, and you should see a screen that says, do you want to allow whatever you named your app to access your data, right? And all you're doing in this case is allowing yourself to look at your data, so it's pretty safe. And then once you click authorize, you'll see a little message that says, you can now return to your R session. And when you do that, you'll come back to your R session, and then you'll be able to start making calls to the API. Okay. Any questions so far? We've gone through a lot. This is a very multi-stage process. Some of you maybe had to start a Twitter account, you had to start a developer account, you had to create an app, you had to name it, you had to put a website in, you had to put a description in, you had to put a callback URL in the right field, you had to uncheck, enable callback checking, you had to get your credentials, copy and paste them, and I should say very often at this step, people have trouble authenticating because they have cut and pasted their credentials inaccurately. So very often you may have accidentally left a few letters off the end, or you may have accidentally put a space in, or you may be forgetting to put quotes at the end of the long string of letters, and your TAs at each of the sites should be able to help you diagnose those types of problems. But if everything is working right, and assuming Twitter hasn't changed this API in the last 3 days, you should be able to get in to their API. Okay. So if you've been able to do that, we can now start making calls to Twitter's API. One of the first calls we'll make is to search for tweets about Korea. Here, we're using the search tweets function, search_tweets. The first argument here is a string that we want to search for, so we're searching for #Korea. This n equals 3,000 says we want 3,000 tweets. And this include_RTS is saying, do you want to include retweets or not? And we're going to say we don't want retweets. By default, we're going to get a mixture of both popular and recent tweets. We can set those as additional parameters if we only want, say, recent tweets or popular tweets. And when we run this, we'll get 3,000 tweets about Korea. You may be wondering, where are those 3,000 tweets coming from, right? We are not able to search all of Twitter. Very often, depending on your level of access, or historically, some researchers have obtained higher levels of access. Very often, we're looking at a micro sample of all of Twitter when we make this type of search, okay? So we're actually not getting all the tweets everywhere about Korea. We're getting a sample. And sometimes that can be okay, depending on your research question. But if your goal is to explain, for example, how information is spreading on Twitter, this is a significant limitation. We're not getting all the tweets very often. Sometimes we are if it's a small search term. But there's also some new work that's been done assessing whether that microsample is actually random or not. And there is some evidence that it might not be random. It might be driven by perturbations in event cycles. That the jury is still out on that one, though. OK, so we are making a call. This function underneath the hood, right? If we could look at all the set of instructions that go into this search tweet function, we'd see that it's doing all sorts of stuff. It's saying, create a long URL that has the name of the Twitter API base URL, just like we did with our Google example. And then it's adding on the names of the fields that we want, here tweets, and however the Twitter API defines that in terms of the exact syntax. And then it's saying, here's a long list of credentials, right? And then it's delivering back to us a large JSON file with 3,000 tweets. And then this function is also taking that JSON data and parsing it and reformatting it as a data frame. So if this has worked, you should see a neat data frame that has 3,000 tweets. And you should see a lot of information about those tweets. So for each of those tweets, we can see the text, the ID of the tweet, which we might care about if we want to keep track of the tweets. We might want to know if it's a retweet. We didn't ask for retweets in our first call, so we probably shouldn't see any. We can see whether it's in reply to another tweet. We can see any photos or URLs, the links to those photos in the URLs, excuse me. We can see the language that's been encoded, English, Korean, and so on and so forth. We can see here, you'll see at the bottom, a number of fields like place name, place type, country code. Here we're getting some fields that are hypothetically of interest, right? So, maybe you remember the first time you signed up for Twitter, one of the questions you were asked is, do you want to allow Twitter to monitor your location, right? The vast majority of people say no. Somewhere around 1 in 100 people say yes, at least as of a few years back, the last time I looked at this carefully. And so what does that mean? It means any of the GPS data we're getting here is heavily, heavily selected, right? Let's think about a few thought experiments. Let's say we want to study immigration patterns using Twitter data, right? And we want to know who is speaking Spanish and traveling across, say, the Mexico border to the US, right? We have to do the thought experiment of how many undocumented people sign up for Twitter and allow Twitter to share their location, right? Probably not many, or at least one type of person, right? And so we have to think really carefully about what that data mean. That's another one of the limitations. And thinking back to our discussion of strengths and weaknesses of APIs, digital trace data that we've been talking about all day, that's a major limitation. Now, there are numerous workarounds that are starting to gain some traction. So for example, we can look at the content of people's tweets. We can look at the content of their bio, their little About Me section on Twitter. Very often people might put their location, like if I wrote, I'm a professor at Duke University, Duke University could then be geocoded using the technique I showed you at the very beginning with the Google API, and Twitter can then say that I'm living in North Carolina, right? We can also do this through the content of people's tweets. So if people are tweeting a lot about things going on in North Carolina, right, we can then make an inference, a very imperfect inference, right? Because again, we were talking earlier this morning about people tweeting about the Arab Spring, right? And how people might be saying, oh, you know, Mubarak has to go, right? And then we might make inferences that people saying Mubarak has to go meant that a revolution happened, right? But what if those people were tweeting from London about Egypt, and then we use the content of their tweets to predict that they were in Egypt, right? That's a huge problem. And it's pretty difficult to get a ground truth there, or a sense of what the actual reality is, right? But there's a number of other fields. So in Duncan's talk last night, if you had the chance to see his talk on the live stream, those of you following along on the live stream, he had a series of predictions about the virality or the social contagious spread of Twitter messages, right? And the model that he built up had a few parameters that went into it, right? Like things like number of Twitter followers, time of day, and all these kinds of things. Many of these tables were pulled exactly through this type of Twitter API. So what time was it created at? What's the screen name of the person or the Twitter handle who created it? What are their hashtags in it? You know, maybe the hypothesis would be tweets that have hashtags in them, these little like hash marks that allow people to search for themes on Twitter. If those are, you know, more likely to go viral because more people are, say, paying attention to a hashtag or something like that. So basically, Duncan's model was taking data from the API, a pretty large data. I believe he was one of the earlier researchers who had greater access to what was once called the Twitter fire hose, which was about a 1 or 10% sample of all of Twitter instead of the micro sample we get today. But nevertheless, he was getting very similar fields to build that model of when things go viral. Okay, so we can look at, if we browse this data frame, here we're using the head function in base R to just show the first 20 tweets. And we'll see we've got a lot of different stuff. We've got some stuff on the meeting between Kim Jong-un and Donald Trump. We've got some actual Korean here. We've got a real kind of hodgepodge of stuff. Again, remember, by default, this search tweets function is returning both popular and recent tweets, a mix of both. And if we just wanted to get the popular tweets, we could specify that. I believe the argument is called type. So you could say type equals popular or type equals recent, and you would get different types of tweets. But so now we've made our first API call, and this is just one of many, many calls. So if you Google API documentation Twitter, you'll see, again, a very large website that describes many, many different types of data that can be collected from Twitter. So let's take a look at a few of those. We can, for example, take our data. Sorry, this isn't from Twitter. This is from the rtweet package. This is some code. It's tsplot for time series plot. And what we're going to do is take all those tweets that we just collected and take the created at field, turn that string object, so that's a long set of words that says like March, or June 13th, 2018, turn that into a date object, which is a different kind of object to a computer. Why is it a different kind of object? It's because time zones are a mess, right? If we have to standardize across time zones, we need to create a date style object. And very often the solution to that is something called Unix time. This is a bit of a tangent, but important. That means the number of seconds that have elapsed since January 1st, 1970. And that's a standardized time metric across a lot of different types of date formats. And so very often in R, we might use the as.date function or the lubridate package to make these type of conversions into or out of Unix time. But just kind of file that in the back of your brain if you haven't worked with date style objects before. It's a bit frustrating. So this time series plot function is doing all that. It's taking our tweets, pulling out the date, and then it's making a nice little visual of the frequency of tweets about Korea here from the past day. All right, so we can do some simple visualizations with these data, pulling out here the number of tweets that used hashtag Korea. And I'm not sure what was going on May 25th, but we could look into it if we were so inclined. Okay, now let's look specifically. We can also ask the API to search by location. So some folks are interested in GPS data, right? And so here we can say, let's restrict the coordinates that we want to search within. We can use kind of a box. We can say we want to look in the southern US, or we want to look in North Carolina, or we want to look in the entire US. And here we're using the entire US. If you want to look up the types of names that you can pass in there, you'd need to read the Twitter documentation. So I'm not sure what would happen if we put Korea, but I think it's probably Korea, but I'm not sure exactly what. Here we're looking in the US for tweets that mention Korea. We've also specified that we want those to be in English using this language argument here. Now we're saying we only want recent tweets and not popular tweets. And we're still saying that we don't want retweets. And we're asking for 1,000 tweets. This then creates an object called nkTweets. I think earlier I had North Korea in there, which is why there's NK. It should probably just say Korea tweets again. And then we're using another function in the package, which is geocoding those texts and extracting the latitude and longitude out of them. And then we can produce a plot using this code, which is just in base R, making a plot that shows us the location from where those tweets were happening, right? And this is nice, but remember, this is only for people who have either enabled location tracking or who have described their location in their profile, right? And many people might not have done either for any number of reasons, right? We can also use the geotagging to kind of specify exactly where those tweets are coming if we wanted to get more involved in this. But for now, I'm just trying to give you a demo of the types of things you might ask from an API. And Twitter's API in particular is a useful place to start, again, because so much of Twitter data is public. Not all of it. There's a surprising number of protected accounts on Twitter. These are people who don't allow people to access their data. There's relatively little research on that I know about, for example, how different those accounts are, or how we might think about whether, for example, private discussions are shaping public discussions. I don't know that we know much about that. Also, I just noticed there's a tweet from the middle of, what is that, Lake Michigan? What's going on there? OK. So maybe we've got an error there. OK, so we've been looking now we've just been doing broad searches of accounts. We can also make searches for individual accounts. So here we are looking at Bernie Sanders' account. We found his Twitter handle by going to Twitter and searching Bernie Sanders. And then at the top of the URL, just like we did for that Facebook page called Donate Life, we saw that little, it's sometimes called a vanity URL that's like some text instead of a number that says what the page is. We could find that Bernie Sanders goes by the Twitter handle SendSanders. And so here we're saying get his timeline, meaning getting all his tweets. And not all his tweets, we're only asking for the last 5 tweets. And then we are going to browse those tweets. And here we can see the contents of some tweets. You will probably see some different ones. This is from about a week or 2 ago, I think. Just going to pause and ask if there's any questions on the live stream or any questions in the room. No? OK. Then, very often we might want to get information about Senator Sanders and kind of who he is. We could get from this function called Lookup Users. We could get a description of who he is. So this will say something like he's the senator from Vermont. We'll get his location, which will say Vermont, I think. We can get his number of followers. We could get his favorite tweets. These are the tweets that Senator Sanders has liked on Twitter. And we can look at the text of those tweets like this, after creating the Sanders favorite object. We can then use our atomic operator there to say that we want the text field that's saying there's a text variable within this object that we are then going to browse. And here's his favorite tweets. OK. One of the really powerful things of Twitter is, of course, the network data, and that so much of the data is public. So we can make API calls to get network data. To get the names of the people who Sanders follows. And this is going to be a relatively large group of people. We're creating, again, another data frame called Sanders follows, which is going to allow us to then look at the, I believe this will produce the IDs, the Twitter IDs of those people. And then we can use our lookup, lookup users function to this one right here, to then, for example, in a loop, go through and get all the information about those people. What's their screen name? Maybe we get their location. Maybe we can get their number of followers, and so on and so forth. OK. So one nice thing about Twitter's API, earlier I mentioned that APIs vary as to whether they tell you what your rate limits are. Twitter allows you to make an API call to check your rate limits. This is done using the rate_limit function. And here we're simply saying, let's create a data frame that describes how many remaining API calls I can make for different types of things. So you're allowed different limits on different things. You can get, you can't get network data as fast as you can get tweets, like the content of tweets for a given user. And there's different limits for different types of data, possibly because they have different size, or also maybe because they're more or less sensitive, right? Depending on the API. But if you run this code, you'll be able to check what your limits are for some of the various fields in the Twitter API. And here we're seeing those. We can make requests to look at lists. We can look at memberships and lists. These are just a random set of fields that you might query from Twitter. And then this is the remaining limit that this user at this time has. Sorry, right here is the remaining. And then you see this time here is telling you the number of minutes until these numbers will reset, and then you can start making calls again. So this is useful because once you know this information, you can understand the rate limits and build pauses into your code, into your loops, that then avoid you from being rate limited, and you can collect data in a allowable manner without being rate limited, and you can collect data most efficiently for your purposes. Okay, so it's great to know the rate limits, always respect the rate limits. Sites will vary. If you repeatedly abuse the limits, you can be blocked from the site, or if you do any of the other kind of obvious violations, like coordinated attacks or promoting. One of the other things Twitter has publicly said they flag is promoting or liking tweets a lot that are a single set of tweets. So many of the bots responsible for the spread of misinformation are a small group of bots that are retweeting, all of whom retweet each other, right? And Twitter has various ways now to try to detect bots, often by looking for patterns in the timing at which they tweet, or whether they tweet about the same things and things like that. And bot detection has become a pretty vibrant field in a variety of corners of computational social science. We can also get trending topics by location. Here we could get the trends for New York, see what those are. We get a data frame again, or a Tibble, which is a kind of data frame in the tidyverse, the aforementioned group of R packages that have a kind of consistent format that's easily portable across things like ggplot, dplyr, which is a package for not manipulating data, for restructuring data. R-tweet can even post tweets. So if we write this line of code, post tweet, I love APIs, your Twitter account will post I love APIs. And I think that function was a little buggy recently. I think I was just messing with it the other day and noticed that there's an issue. So if that doesn't work, there may be a GitHub that you need to check to make it work. Note, this is a very useful function if you're building a bot for a search, which we're about to talk about in one of the next sections. So of course, just like with screenscaping, we've been doing one singular call for one piece of information. And very often with APIs, we want to request a lot of information about a lot of people. So Duncan's talk last night wanted to track a lot of tweets to see which ones went viral, right? And he showed us most of them are not going viral and the rest are. So you needed some kind of way of creating a sample of tweets. So one way would be like, let's say we had a list of elected officials, and I posted one on my GitHub here that you can download using the read CSV function. And if you run this code, you'll create a data frame that looks like this. And it is saying, here's the senator's name, and here's their Twitter handle. And once we have this type of data, we could then loop through all of these Twitter handles and collect some type of information about them. So what might that look like? Probably something like this. So here we begin by creating a blank container, a data frame that we're going to populate each time through the loop with information about each elected official. We are going to say for each iteration through the loop, I is an abstract variable that's going to take a value between 1 and then this value, which is the number of rows in our data frame. So it's between 1 and I think 562. Each time we go through our loop, I is going to take a different value. And I here is changing each time we pass the elected official's screen name. We're going through that long list. But first, we're checking our rate limits and making sure that we aren't above our rate limits. Note, however, I think it's possible this code might not work because checking your rate limits is rate limited. So if you make that call a bunch of times within your loop, you may want to make this outside the loop. I think I've experienced that issue once or twice with this code. OK, and then finally, here's where the action is. We're getting the tweets of the last 100 tweets of all the elected officials. We're going to work with this data tomorrow when we do text analysis. And we're creating a data frame called tweets that we're populating. We're adding a row each time through the loop. And the code is cut off down here, but you can see at the end we use an rbind command. And if you're looking in the markdown, you can see the full code. And we're populating a data frame called elected official tweets. So if you've never written, and usually it's the case, we have at least a few students who maybe didn't do the data camp as closely as others, or you're newer to coding, and that's fine. If this is your first time seeing a loop, it may be it may seem somewhat strange, or why do I have to define a container, and what is this abstract variable thing? You're really going to want to develop fluency writing loops and functions because this is just something we do all day, every day, if you're in the business of collecting data from APIs. So if you are struggling to follow along with this, work with your local TA or go back and check out the data camp on loops. Okay, so we now have a series of packages that discuss Facebook and how to make calls to Facebook's Graph API Explorer. If you go back to this site, we need to get credentials for Facebook. And so we do that by cutting and pasting the access token at the top. There's other ways to authenticate yourself vis-a-vis Facebook, but just for the purposes of illustration, we're going to do a simple way. That access token is actually going to expire after about a day, so we'd have to continue getting the access token this way. We could do a more permanent solution if we wanted to go and register as a developer. But for now, we can make some simple calls by installing the rFacebook package, loading the rFacebook package, and then passing the token that you just got from the Graphic API Explorer to create an object we're going to call token. And then we can do pretty much many similar things that we did with Twitter. Right? So we can get information about ourselves, or say a public fan page, or something like that. We can get, I don't know why you'd want to get your own likes, but this is a limitation of working with Facebook data, right? You can only get information about you and your friends, which may not be of interest to reviewer B, right? But we can do a lot with public fan pages, right? So let's take a look at Duke's page, facebook.com/Duke this is the vanity URL that I was talking about earlier. We're going to take that Duke univ and put it into another function called getPage. This function also has an argument called token, which is allowing us to, again, this single function is doing lots of stuff. It's stitching together a URL with a long string of instructions and a query language and an access token, and putting it all together to make that URL get the data, in this case, again, JSON data, and parse through that data, restructure it, make it into a neat data frame, and then this should produce a data frame that has a variety of posts that Duke University made. So we've gone over examples with Twitter and Facebook. I just want to point out there are packages, and if Python's your thing, there are many Python modules for working with APIs as well. Here's a few popular ones: our Google Maps, our Facebook. Our OpenSci has a list of really great different APIs, including, for example, the Internet Archive. This is the site that periodically takes a snapshot of a site, usually every month. And so that's a really interesting data source to go back and look at how things have changed over time. World Development Indicators, Open Government, New York Times. The list really goes on and on and on, and you can find many, many more on GitHub. And to work with GitHub packages, you'll need the DevTools package, and I'll show you how to install a GitHub package a little later. Again, there are also APIs that do analysis for you. I mentioned earlier facial recognition, also in this case visualization. There's an API known as Plotly that does interactive plots, and and many other APIs. And I think young scholars can really get exciting data simply by doing some simple searches for the topic you're interested in an API. You'd be surprised how much data is up there. If you're interested in politics, the ProPublica or the Sunlight Foundation has produced a massive treasure trove of information. All of the IRS data on nonprofit organizations is up on APIs now. There's lots and lots of data which is unexplored, mostly because most social scientists don't know what an API is and don't know how to access it, right? And so those of you who are in this great position to take on these new data sets should check out, do some searches on programmable web and see if you can get some neat data. And especially maybe merge it with other data, which is what we're going to talk about in the next section of the lecture. But before we do that, I just want to mention that you might encounter the situation where there's an API that you'd like to work with, but there's no R package, right? And that's too bad because, as I said, these functions are doing a lot for us. But actually designing your own API calls is something you can do. In fact, we did it at the very beginning of the lecture, right, when we made our Google Maps API URL, and then we saw the JSON data, and then we'd scrape that data. So the trick with designing your own API calls is, again, figuring out what these components of the URL are, right? What is the base API? What are the fields being requested? How do you specify the data format? Where does the query go? How does the credentialing work, right? Where does the token or secret or credential that you need to pass to identify yourself before the API, where does that go? Does it have some field before it and a question mark and an equal sign? These are all the things you have to figure out, and these will be described, hopefully neatly, but often not neatly, in the API documentation for a given API. And the larger the API, the better it's documented, the more people working with it, the more you can depend upon communities like on GitHub to learn how to work with it. If there's a Python package but not an R package, go check out the Python package. And even if you aren't able to, say, read Python, you might be able to see how they're defining the URLs and make your own equivalent in R. This is obviously an advanced topic, and many people won't want to do this. But if, for example, you discover that there's a killer API that would really make your dissertation, it may be worth, working through writing a function or two to help you make calls. And who knows, maybe you could then make an R package and put it on GitHub and help out some other folks. And that kind of gets back to the generosity value we're trying to promote here. Okay. Any other questions on the practical components of working with APIs? And nothing from Slack? OK. So challenges of working with APIs. There's a number of them. So one is credentialing. The other is rate limiting. We've talked about that. A third one is, the data you want might not be on the API, or you may have to pay a lot of money for it, or you may have to get permission to access it, or you may have to get permission from lots of people to access it. And that's even more complicated, right? Think about the steps you'd have to go through to write the code to do that. Another limitation is, of course, that a lot of the most interesting data is still behind closed doors, right? It's in industry. And many of us are working to change that at high levels of creating collaboration with industry, working with various funding agencies to try to design solutions where we can facilitate access, maybe in a restricted manner, but on something like on the model of our other restricted data sets. But it's really hard work. And we are all working hard on it, but it means that these things won't change tomorrow. But on the other hand, hopefully by now it's clear that APIs have a ton of advantages over screen scraping, right? It's legal. It is, you're allowed to make custom requests. Your data come in a neat, easy to work with format. And you can define exactly how much data you're allowed to get and from who and when. So those are the main advantages. OK. And here, this one might be most interesting to folks. This is a public spreadsheet that I curate that is a kind of a crowdsourced list of APIs that are of interest to computational social scientists. So please take a moment, click on that, check it out. There's probably many APIs on there that I don't know about. And one of the neat things is now with the addition of some 300 people following along online, maybe we can put a lot more lines on this spreadsheet. And the things that are up there are things like the New York Times and Facebook and various Amazon APIs and Google APIs. But again, dozens and dozens of APIs are coming along each day at this point. So, and not all of them will be of interest to social scientists, but many of them might. Okay. So that wraps up our discussion. And sorry for those of you on the live stream, I can't take a poll of you, but I'm thinking maybe just like a 2-minute break. Does that sound good to folks? We can get coffee or use the restroom. We'll come back and we'll talk about a really exciting topic that I'm really passionate about, which is building apps and bots for social science research. So I'll see you in, oh, sorry, there's one question, or?
Andrew Wolf of NYU asks, given the issues of only getting a sample, what types of questions do you think we can answer, and what types of questions can we answer?
Yeah, so this is a great question. Obviously, there's limitations. It depends on the question. I think generally speaking, like if you're using Twitter to take the pulse of sentiment on a general issue, I think generally speaking, it's not crazy to do that. Again, admitting the limitations and maybe discussing them in detail in a footnote or an appendix of a paper. But I would also encourage you to think not just about using the search function, which is relatively constrained by this sampling issue, and rather defining a universe of people to sample from. So the example we just had was looking at elected officials. There we have a predefined sample, and we can get most of the data that they produce. We can get the last 3,200 tweets from all of those elected officials. And there we actually are getting the whole population. We're not getting all their tweets. We wish we could get, say, 10,000 if they've tweeted 10,000 times. But that's another strategy. So in other words, we don't always have to depend on the random sample if we can define the sample ourselves. Yeah, yeah, Marcus.
What's that?
OK.
You just asked.
So let's take a 2-minute break. If anyone else on the live stream has questions, Slack them to us, and I will get back to you later. OK? 2 minutes. We'll see you in 2 minutes. develop some hybrid approaches in this section. And this is going to dovetail with some of what Matt will talk about on Thursday when he talks about surveys in the digital age. I'm just going to give you some templates, ways to think about creatively combining digital trace data with other types of more conventional tools in the social scientist toolkit, such as surveys or field experiments. So let's take a look. Let's start off. I want to organize the discussion around the set of strengths and weaknesses of digital trace data that we set out with, which draws from Matt's book. And we're going to talk about it in the context of apps. So as you may recall, we identified the following limitations of digital trace data: that it's incomplete, or all the data we want is sometimes not there for a variety of reasons. It's inaccessible. It's hidden behind paywalls or behind private data sets. It's not representative. We don't know who's tweeting about what, where. There's drifting, right? People moving across platforms changing. There's algorithmic confounding, properties of algorithms embedded in social media sites or search sites that make human behavior look like something it's not. It's dirty, it's unstructured, it's difficult to work with. And it's sensitive, right? That there's often cases where we're collecting quite a bit of data about people that would be, it could be harmful if it got out in the world. So I'm going to try to argue that we can't throw the baby out with the bathwater. These are serious limitations, but what are the alternatives? So survey response rates continue to drop, right? One of the last surveys I did had a 1% response rate. And that was from a pretty reputable polling firm. And this was a while ago. This was maybe like 5 or 6 years ago. One of the last conventional surveys, I'll say. And many of our most important questions require this type of data, right? Longitudinal data to look at change over time. Relational data to look at how social relationships are changing things. And also qualitative data, right? So many of our most important questions are about which ideas spread and why. Why do people think certain ways? Text is so obviously going to be an important part of the future of computational social science and probably social science more broadly. So are we really going to leave these data alone? I think not, and I think there's also some other advantages that digital trace data have that conventional sources do not. Again, that they're typically larger, that they're always on, that they're collecting data all the time, or most of the time, we hope, and that they're non-reactive, that we might avoid social desirability bias. So the question I would like us all to think about is, can we have our cake and eat it too? Is there a way that we can work with digital trace data, but maybe merge it with more conventional sources of data collection, like a survey? And I'm going to argue that apps, if we build our own apps, that's a really interesting way to try to think about getting around some of the problems and really making some of the good parts even better. So I'm going to argue that apps can help us address the incompleteness of data, the inaccessibility of data, the non-representativeness of data, the dirtiness of data, and the sensitive nature of data. So what do I mean by an app? In my own work, about 5 or 6 years ago, I had been doing a lot of work with Twitter data, a lot of work with Facebook data, collecting a lot of the fields we were just looking at, right? Like things like the number of times something was retweeted, what time of day it was tweeted at, the number of followers of the person who tweeted it. And I could build a model kind of like Duncan Watt's talk showed last night that could maybe predict some useful some useful theory of why information spreads. But then someone might ask me, okay, Chris, well, but how do you know those aren't the same 10 people in the same dorm room spreading that information back and forth to each other? Or how do you know that it wasn't only women who shared that? Or it wasn't only people in North Carolina, right? Or it wasn't that offline people were all doing one thing that then had some effect on their online behavior, right? And I couldn't answer any of those questions. And I got kind of bummed. I was like, maybe, and remember in our hype cycle that we've been showing throughout the day, right? This was the trough of despair. This was my trough of despair. Like here we had this great data. And a lot of my work is on the spread of ideas and culture, right? And so I was so excited about these data, and I had written pieces about the great value of these data. And yet I had this reckoning. I realized we needed to do something. So the solution I came up with was to build an app that would allow. I was studying nonprofit groups and trying to understand how their posts go viral in a number of ways. And my internet connection is being buggy here, and I can't spell. And I've apparently got a virus. Great. Okay, so here, the trifecta. Here's the app that I built many years ago. And essentially, here's the idea. So you are a nonprofit organization. I want to know everything about your posts and try to make better predictions of which ones are going to go viral. You, as a nonprofit organization, actually want to know the same thing, right? You're trying to call attention to your cause. You're trying to get people interested in what you're talking about, right? Wouldn't you like a complimentary audit of your social media outreach, right? So here's the deal I'll make with you. If you install my app, right, and agree to share your data with me, my app will deliver to you a report about how you might improve your social media outreach based upon a comparison of your data to that of your peers, all of the other people who have installed the app, right? And at the time, apps were a new thing, and many nonprofit groups really wanted to know what was working, right? Nobody knew, and I'm not really convinced anybody still knows, right? And so here's how it works. So the representative of the organization, we have a sampling frame. We send them an email that says, there's this tool you can use to optimize your outreach, right? They click here. They're then redirected. It no longer works, so if you're there, our cloud server is down. We've deprecated the whole program based on an API change, actually, and the study concluded long ago. But anyways, if you click there, you're then redirected to, or you were once redirected to an authentication dialog. And there, the user is saying exactly what type of data they're sharing. And there's a privacy policy linked, which includes an informed consent dialog and allows the researcher to specify very clearly exactly what type of data is being collected and exactly for what purpose and exactly how the data will be stored and all of the other wonderful principles of informed consent that we all should follow, right? And have to follow if your research is reviewed by an IRB. But even if it isn't, right, as our discussion of ethics hinted at yesterday, we need to be attuned to these things and need to hold ourselves to a standard that's higher than IRB, right? So in other words, the app is a contract with people, right? We are proactively asking them. We're being very forthright about what we're doing. And then as soon as we get authentication, right, then the app can make API calls to start collecting data of interest. In this case, I was gathering both the data that are public, so things like the text of the post and the number of times it was liked or retweeted, but also non-public data that is available to the owner of the page that they chose to share with me. So these are metrics like the number of women aged 15 to 35 who clicked on a link on January 27th, right? Or the number of people in North Carolina who clicked on a link. Or the number of people who moused over a link but didn't click on it, right? Some pretty rich data, about 100 additional metrics that I couldn't get without forming an individual contract with the user, right? Then, on top of that, we survey them. So after you go through the authentication dialog, you're redirected to a brief survey, and then you're asked, the representative of the organization is asked a series of questions that we can't measure from all those data. Things like, what is the annual budget of your organization? What do you do offline to call attention to your cause? What are the other, all these confounding factors that I was discussing earlier that I wasn't able to answer with the digital trace data alone. And once they finish the survey, they then get a report back with a series of visuals like this that tell them where their audience is coming from, how the size of their audience compares to other organizations in their field, what types of demographics they're doing well in and what they're not doing well in, and so on and so forth. Yeah, Jeff. Mm-hmm.
How do you bootstrap an application like that, right? Like the first few organizations
Yeah. Yeah, so we worked with a set of partner organizations to calibrate it up front. Yeah, so we had an initial sample. And by the way, like, I'm glad you brought that up because one of the other nice kind of byproducts of building apps is and not all apps need to do some good in the world, right? Like that need to help nonprofit groups. You could also pay people to use apps, but something like this ties social science to real problems in the world. And so there actually was a surprising amount of interest among the nonprofit groups we worked with to figure this out because they were all kind of scrambling, especially back in 2010, 2011 when this was going in the field, when everybody was really trying to figure out what makes something go viral, right? Yeah, good question. So we've got the public data, we've got the private Facebook data, and then we've got supplemental survey data. And I should say, and I want to be very clear about this, the private Facebook data that we collect was all aggregate data about audiences. So it wasn't the name of the person who clicked on a link. It was that a count of a number of people from a certain demographic who clicked on a link. Even though, in theory, you could get that name if you wanted to make that contract with the user, but that's obviously much more controversial. And if we look at the case of Cambridge Analytica, which is in the field the year after my study was in the field, that study did not have as clear informed consent, I would argue, in part because we talked about international differences in institutional review boards. Because the study was led at Cambridge, it had much more, I think, modest or imperfect review, right? Shall we say, right? Which of course led to this huge, issue, which actually Facebook responded to by changing its API. It was called Graph 2.0 to Graph 3.0. A major change was you weren't able to get information about friends of friends, and that was actually in response to the Cambridge Analytica breach and other similar apps that had violated that. So thinking through this at a time when you'd call the IRB about this and they'd say, nobody's ever built an app for social science research support. Now it's all over the place. We have many examples of this, but so we're still working through these issues. But I think provided that we are careful about our public release of data, which is something we should talk about. We don't have on the curriculum, but hopefully all of you will discuss over lunches, and all of you on the live stream might discuss as well. It's really a vitally important issue. Okay, so we've got public data, private social media data, and we've got survey data. And we can start to look at, things with a much more careful lens, right? We eventually came to call this a social media survey app. And so these could probably be a class of web or mobile-based tools built by a researcher in order to collect some public or private data produced by social media users from an API, likely. Collect some type of supplemental information from them, such as demographics, using more conventional survey methods. And offer some type of incentive back to the user, something like an analysis or a financial incentive, right, to inspire them or to encourage them and to share their data. Again, using clear language that describes how the data is going to be used. And that was one of the issues with the Cambridge Analytica app, right? It just asked you, what's your personality? And it seemed like an innocuous thing that wasn't going to not only take your data, but your friends' data, right? So provided that we are clearly announcing ourselves as researchers. And that's a limitation, right? If you're interested in doing, for example, field experiments, this might compromise some of the science, right, if people knew that you were researchers. And we'll talk a little bit more about that when we talk about bots in just a second. So here's a paper linked here that discusses the various advantages of this hybrid strategy. Here is, from the paper, some ideas. We used to call it big data back then. The steps that go into an app analysis. You authenticate with the user. There's some type of big data extraction. There's some type of supplemental data collection, maybe in a survey. There's some type of app analysis, and there's some type of app report that then gets delivered back to the user. So here's an example of how the Vir algorithm worked. It not only collected Facebook data and survey data, it also added data from Google to look at the effect of the broader environment of events. So for example, We were studying groups working on autism spectrum disorders or organ donation, and we discovered that we needed to know what was public interest in autism on a given day, because that was something that was going to be a confounding factor in terms of whether a message might spread, right? If there was a public controversy about autism spectrum disorders, we wanted a measure of that. So we collected Google Trends data, Google News data, Google Blogs data, and meshed all that up in a cloud server, then returned that to our app and delivered it to the user. So we were nervous when we did this first. We thought that even back, now today things are even more complicated in terms of whether people are willing to share their data. But back then, this was one of, or maybe one of the first studies in social science to use an app. We thought people would be scared of sharing their data. We got a response rate of about 40% of groups, which is pretty good, at least according to meta-analyses of organizational populations, which typically have higher response rates. We did reach out to them by phone, though, and I think that had a big effect, and on university letterhead. So that was a much higher cost recruitment. We saw minimal evidence of selection. So we didn't see that groups were, for example, installing the app if they were poorer, because maybe they had less resources to hire a social media consultant. We didn't see younger or more recently founded organizations more likely to use the app, because maybe they were more interested in social media in general. And we didn't see differences in the number of people who are using the app. So that was encouraging. But importantly, we could look at these data points to some degree, right? And we could look at the representativeness of our sample using all these demographic variables that we collect. And we can also use post-estimation weighting. We can start to try to assign a weight or an increased influence in a model to a person who's from an underrepresented category. And the important thing here is that we know what groups are underrepresented because we collect that supplemental data. And so here's a series of papers that describe in excruciating detail more about the payoff of apps and how they can be used for social science research. Questions so far? Anything from the live stream? Has anybody here built an app? Okay. Well, if you had built an app, you discover historically there have been some challenges. One is, at least a long time ago, when I was doing this, you needed significant coding skills. You needed to know HTML. You needed to know CSS. You needed to know something about cloud computing. You needed to know something about reactive programming. All those things, because of new tools that I'm about to show you, are now no longer necessary, or are necessary in a much, much easier to use format. But there's still another limitation, which is that there's a competitive environment for attention, right? Everybody's got an app now, right? So how are you going to get your app to get attention? Apps are no longer new. Now we have even more concerns about data sharing and privacy. That's another limitation. And compelling incentives, if your app is going to develop an incentive to offer an incentive to a user, those are hard to identify. Though again, we've done some new work looking at offering financial incentives to get people to share their social media data that again, with fully informed consent and disclosure about precisely what type of data would be collected. And we've discovered large numbers of people are willing to share their social media data for financial compensation. So that is another vehicle. And indeed, one of the ideas on the table, moving forward, we were talking about earlier about how many of us are working to try to promote access to industry data. One of the models that's floating out there is to allow someone who runs a survey to have some type of restricted access API that would allow you to then request pre-specified tables from the API that could be merged with your survey. So for example, if you were doing a study where you needed to know about how much exercise someone is getting, you could imagine making a call to a Google server with Maps data to ask the number of steps someone took in a day, right? You don't want to know that they went to Starbucks at 4 p.m., but you want to know the number of steps that they took. All that analysis could happen on a Google server, could be delivered back to the survey firm, and then merged with your survey, and you could get a really nice, clean measure of something, right? That's one of the ideas on the table, but again, it's a logistical nightmare of multi-factor encryption and many other engineering challenges. Okay. So how would you build an app? And again, we're not going to go through every step. We don't have time. But I want to show you some new tools that have really reduced the startup costs, especially in R. And there's equivalent programs in other languages. But one that's really nice, and many of you have probably already used, is called Shiny. Shiny is a tool to create interactive apps natively within RStudio. So if you are in RStudio and you go to File, New, and then Shiny App, a toy example will open up. It's going to be a visualization of a histogram that you can mouse over and interact with, and it's just kind of a very simple, clunky app. Here's an example of another one. If it will load here, let's see. Sorry, I'm having some internet connection issues here. Let's try to find one quickly. This is always dangerous. Here we go. Here we've got an example of a Shiny app. We are mousing over, looking at here health expenditure versus life expectancy. This is not really an app in the sense that we're just talking about. It's really just a tool for a user to interact with data. And here we're seeing the code that actually goes into building this app. And I'll talk about what each of these different parts of the code here mean in just a minute. But what's really neat is once the app is made, RStudio has a publish button that allows you to then put the app up on the internet, and then allows you to also host it at pretty high volume. If you expect it to have a lot of users, you can pay a little more to host on a higher volume server. So it really does allow you to avoid all the steps of registering with a cloud computing account, handling the CSS and the HTML to make it look in the way you want, and all of those challenges that I mentioned earlier. Now the trick is, of course, this is just a simple interactive visualization. If you wanted to embed a survey and store that data with safe, with very secure passwords, perhaps, you could imagine doing something like that with a few of the tools we've been working with, right? So you could imagine using the R-tweet package to authenticate, right? And make calls for users' tweets, and then administer a survey within a Shiny app by creating objects within the Shiny app, as I'll soon describe how to do, that say, what is your age, what is your gender, and so on and so forth, and then add additional sets in that script to say, send that data to a server somewhere where I'm going to store my data, all right? So there's three components of a Shiny app. There's one, historically these were separate scripts that then had to be compiled. Now they all come together in one script where you define these three things. One's called the global part of the script. That's where you define variables that you might want to work with in both the user interface, what the user is seeing on their screen, and then also what types of analysis that the app itself is doing. If it's producing a visualization, what data is it loading and how is it analyzing it? What type of visualization is it doing, a ggplot or what, right? That's also in this server script where you would be specifying where to send or retrieve data from some type of API. And then the user interface is where you would do things like define a text box where a user could enter in their text, right? And then maybe create a global variable that would pass through that user interface to your server script to do some type of analysis. So the global part of the script is, again, the kind of the memory of the app. It stores things you want to call from other parts of the app, the user interface or the server. The server you can think of as kind of the brains of the app. It's where the analysis is going on. It runs the analysis you might want to show a user, but it can also store data generated by the user or expose users to different types of information if you wanted to embed an experiment within your app, for example. And the user interface you could think of as kind of the face of the app. It's what the user is going to see on the screen. Is there going to be a visualization? Is there going to be a text box? It could load fancy images or logos and improve the overall appeal of the app too if you wanted to make it attractive and visually appealing, right? So obviously we haven't really worked through all the details, but this is the architecture of a Shiny app. User interface, you've got some kind of widgets or text boxes that would allow you to collect, say, your survey data. Then you've got your server script, which is loading data, maybe making API calls if you want to build an app that merges survey data and API data. It's doing some type of analysis, and it's outputting something back into the user interface for the user to look at. OK, so you're probably thinking, if you've never worked with an app, because nobody raised their hand, that, OK, well, this sounds like a lot of work. And that is true. However, and this is where it gets really exciting, there's lots of people building lots of apps who all share their code online. So for example, let's say you wanted to build an app that integrates Twitter data with survey data, right? There are various websites. One I like is called Show Me Shiny here. And this is a website that will contain a ton of different Shiny apps. And each one, or at least most of them, will include the source code. And so if you come here, you can, here's a GitHub, I think with the, or no, there's a no longer working page. Anyways, I promise many of these, here's the code, will have the type of scripts we were just looking at. Here's the global script, the server script, the user interface, and we'll even sometimes in great detail show you the documentation. Why am I showing you this? Well, if it's the case where you want to build an app that collects Twitter data and survey data, for example, find an app that makes Twitter API calls, and it might be as simple as switching out some of the parameters to do the analysis you wanted to do or deliver to the user instead of the analysis that the app that you're hosting on. And this, by the way, this kind of, this is what, in this world, if you're not yet comfortable with the idea of using other people's code, this is how so much of our world works. We depend upon each other. And so, we all love the innovator who can produce the first code that's critical and vital, but many of us, even at the most expert levels, are borrowing heavily from other people's code. Why? Because it's so hard to have all the skills to navigate, from, say, survey design to HTML to, say, experimental design, right? And this is another reason why team-based research, right, where maybe someone has better engineering skills, but someone has better experiment skills, and another person has better survey skills, and another person has qualitative knowledge or theoretical knowledge, right? These are the teams we need to put together to do the best research, I think. OK. So check that out. There's lots of great templates. You might find yourself able to build a Shiny app in 5 minutes. I mean, maybe not one that does everything I just showed you, but a simple Shiny app. Great for teaching, too, as an aside. And you could link to cloud servers through the Google Drive package or other packages available in the tidyverse. And again, app hosting is available from RStudio. OK, so in the 15 minutes we have left, I want to talk about a really exciting new field of research, which is using bots for social science research. Right? We think, and if we're reading media accounts lately, we've seen numerous examples of how bots have done terrible things in the world, right? Spreading misinformation, distributed attacks on websites, right? And yet at the same time, the study of bots, what they do and how it's really in its infancy. I think there's a lot of new research coming online on that, how bots spread information and how, which type of people interact with bots and how and whether they know they're interacting with bots and all these type of interesting questions. But we can even go further than that, which is itself an interesting line of research, which is to actually build our own bots to deploy in, say, field experiments. So here's a nice example from last year. A very entrepreneurial PhD student in political science discovered that he could build a bot with a very cute title here, Tweetman Effects on the Tweeted, that would experimentally sanction people using racist language on Twitter. And so he built this bot. Here's one of the bots here, and here's another one. And so here's someone saying something racist, and the bot would search for people saying racist, probably using a call to the Twitter API like we looked at earlier, right, and get a database of people who had said some type of racial slur. And then he built 2 bots. Actually, I think ultimately there were 4 bots, but the important difference between the bots was that some of the bots had an avatar with a dark-skinned avatar, and some of them had an avatar with a light-skinned figure. And both of them said the exact same message, something sanctioning criticizing the person for using the racist language, right? And of course, dispatched this in an experimental manner, so I had a control group and a treatment group, and finds quite interestingly that people are the people who use the racial slurs are much less likely, or significantly less likely to sanctioned by the white avatar than by the dark-skinned avatar, the African-American avatar. And so showing that, the nice contribution around showing how the effect of those criticizing racism could potentially stem the spread of racism. The paper, I think, is not perfect. There's some issues of post-treatment bias or attrition in the sample, which is another example of how our data can be incomplete and imperfect. But I think it was just a really creative and nice idea to think about using bots for social science research. And so my group here, and some of our TAs here have been involved in this, has also been using bots, but for another purpose, which is to study social media and political polarization. And so in this study, we recruited a panel of about 1,600 Republicans and Democrats. And we administered a survey to them. And the survey asked a range of questions about their political beliefs, especially attitudes about the other party, but also substantive issues around, what do you think of climate change? What do you think of government regulation of the economy? Things like this. And we also asked them for their Twitter handle. And of course, we in our informed consent dialogue, carefully described how we were going to use the Twitter handle and what type of information was going to be collected from their Twitter account. And importantly, that we were also going to merge their Twitter data with their survey data, which, as you can imagine, is a really sensitive data point. OK, so we ran that survey. And then once we had their Twitter handle, we began scraping much of their Twitter information, their tweets, their networks. We used that, interestingly, to identify people who were, as far as we could tell, lying about their identity. So when we cross-referenced our Twitter location fields with the self-reported zip code of the people who had taken our survey, we discovered that 62 of the people who claimed to be, Republicans from Oklahoma who voted for Clinton or Trump were actually unemployed Venezuelan computer programmers who had used Tor to mask their IP address in order to deceive our survey firm to take the survey, right? 65, pretty big number, pretty good survey firm too, which was concerning. Also, we use that data to collect network data, right? So we can know if anyone in our sample is connected to each other on Twitter, which is going to be important for us because our treatment is going to be exposing them to outpartisan information. We discovered that about 190 people in our sample were either part of a large network component, a large cluster of people who are connected to each other from someone else, or were part of network dyads. And so when we thought about it, when we go to do our treatment with our bots, if we treat one person and not the other person, and that person starts retweeting the stuff our bot is retweeting, then we're treating the 2 people. And then when we go to subtract the difference between the 2, we've got a big problem with causal interference. And we were able to tackle this problem, too, by merging digital trace data with survey data. OK, so that's just everything before the treatment and before the bots. We then, 1 week later, in an ostensibly unrelated design where we stagger the invitation or the treatment, the subsequent survey, we built bots that randomly retweeted messages produced by a population of opinion leaders who were either Republican or Democrat using some network-driven sampling message developed by a fine scholar I mentioned earlier, Pablo Barbera. And we get elected officials. We scrape the names of the people those elected officials follow. We build a large graph of people who are followed by a lot of elected officials, which we use to infer the ideology of non-elected officials. Then we have a great big graph we do a correspondence analysis on that graph. We pull out a feature that is a left-right continuum. It's crude, but it's roughly follows party. And then our bot, which is hosted on a cloud server, is randomly drawing from those two populations and exposing our Democrats to Republicans if they're in the treatment condition, and then our Republicans to Democrats if they're in the treatment condition. So our bot is just randomly retweeting the bot. Then we use surveys to monitor whether people were paying attention as well. So our bots would once a day tweet a picture of a cute, adorable animal. And at the end of the week, we would delete all those tweets and then resurvey the respondents in order to determine whether they could identify the picture of the animal that our bot had been tweeting, so we could measure compliance with treatment. And then finally, at the end of the experiment, we are also re-administering the original survey in order to calculate a kind of difference in difference, a change in political attitudes over 1 month treatment period during 2017, October 2017. And so the thing that I think is neat and relevant to our conversation today is that we're combining digital trace data and survey data, and we're learning a lot, right? We were able to identify these problems with the data quality issues, causal interference issues, but we're also getting so much that we can't get from the Twitter data. Things like demographics, things like other variables like whether or not someone voted that turn out to be very important for our research question. And also we can embed a field experiment within this design using bots, right? And so just in case you're interested, we found that here's different levels of compliance. Here's Democrats, here's Republicans. If they move left, they're becoming more liberal. If they move right, they're becoming more conservative. And this is, again, the difference in difference estimate, so who changed in treatment compared to control. And we find that for Democrats, when they were exposed to the Republican bot, they didn't change terribly much, right? They became slightly more liberal, maybe. There's some issues with our, the estimate we have the most faith in is this one. These have some issues with the assumptions that I could talk about if anybody's interested. But look at the Republicans here. Moving almost 3/4 of a standard deviation, becoming more conservative in response to being exposed to our liberal bot. And this has provoked a series of follow-up studies now on asymmetric polarization and exposure to outpartisan information. And so without going into the study too much, I just wanted to, again, signal the value of hybrid approaches, which, as I mentioned earlier, the days of publishing a paper with just Twitter data that just, for example, build a nice network plot, right? Those are long gone for all the reasons that we discussed at the beginning of the morning, that all the weaknesses, the non-representativeness, the inaccessibility, the drift, the algorithmic confounding, right? And combining surveys with digital trace data and using bots to run field experiments or embed field experiments within this message gets at some of that, but there's still questions remaining, right? About, for example, algorithmic confounding. So one of the challenges for us was trying to figure out whether Twitter's timeline feature, which is now sorting like Facebook's, to promote things that people are more likely to like or interact with, was in fact shaping our results somehow. And we took a number of steps to try to do our best to get around that problem, but we couldn't know at the end of the day that there isn't something inside Twitter driving that result, right? And you could say that's still a finding about how Twitter works, right? And this is an important distinction. Our research question was about how this is unfolding on Twitter. We would be very hesitant to draw inferences about that would generalize our findings to the general population. So, okay, so in the few minutes we have remaining, how do I build a bot? So obviously, there are a range of ethical issues involved in bot construction. Twitter has a web page on its automation policy. I can't describe it in detail for you because it's very long, but the two key things that are expressly prevented are bots that spread information or bots that do some type of coordinated or distributed attack on either a given user or a website, and especially those bots that repeatedly like or retweet things, which have been shown to be central to these misinformation campaigns and networks of bots on Twitter. Okay, so all that said, you've done your careful research, you've gone through IRB review, And importantly, and this is again another theme from Matt's lecture on ethics yesterday, you've taken the extra step of talking to your colleagues and really thinking carefully, not just about what you would like, right, if you were exposed to bot, but if someone else was exposed, right, and thinking of the experiment and this is important for any number of reasons, including the increased scrutiny of our field and your obligation to future researchers. So here's an example. This is a very, very simple bot. This code assumes that we have authenticated with Twitter, right? And what this bot is going to do is every day it's going to search for tweets about computational social science, 50 of them, pick one at random, and tweet it, and then sleep for a day, and then repeat. Okay? So this is a very, this is a clunky bot. Maybe one of you will build this bot. That would be cool, I guess. I don't know. So you can imagine this could get much more complicated, right? In the case of the Munger paper I mentioned earlier, right? We might use search tweets to look for racial slurs and then do some type of careful review of those. I think in his case, he actually reviewed it by hand, but you can imagine doing it programmatically as well. Then you'd need some type of randomization, or you'd need some type of sampling frame if you are going to run a whole experiment, right? You could imagine embedding various forms of text analysis in here to extract features from the text that then could be related to the field experiment. The world is your oyster here, but you can imagine a lot of different stuff going into this code. Typically speaking, we would host something like this on a cloud server, something like Amazon EC2 or Google Cloud Computer. And we could, there are instructions about how to spin up one of those servers in the annotated code that is linked on the main web page. And here's an example of how you might make the bot interactive. This is from the Munger paper. This is his kind of decision tree that says exactly how his code was sampling tweets before he replied to the racist tweets. So obviously that could require a lot more coding and skill. And hosting a bot, again, something like Amazon Web Services, you would want to use that to both probably host the bot and maybe store data that is collected by bots' interaction with people. We've already discussed some of the ethical issues here. Again, let's keep this in our minds. And if you're interested in more detail about how to build apps, I'd be happy to share the code that we use to build our bot, which will soon be posted on the Open Science Framework, which I think Matt's going to talk about next week. You're talking about Open Science Framework. Yeah, so I think we are out. We have time for maybe one question, unfortunately, because we're right at 12:30. Yeah.
Well, we have one question.
Oh, great.
Austin from Cooney Hunter wanted to know, is API extraction here to stay, or do you think that it is only a matter of time before it becomes outlawed, banned, like screen scraping?
Huh. It's a good question. I can't see the future. I would say I don't think it's going away because, again, it's become a very convenient way of ensuring safe, secure access to those who are allowed to access data. Whether we might see more efficient technology to do that, I'm almost certain that we will. But I think the principle of researchers needing to form a contract with an organization that maintains an API is something that we will see for a long time to come, because we have to find some kind of sweet spot in between, everybody gets access to all data and, only people inside an industry group get access to that data, right? And that, like, the internet wouldn't work if we went to that extreme, right? So I think we will continue to work to find that sweet spot. I can't say exactly what it will be, but I think something like an API is here to stay. Yeah, thanks. Okay, so the group exercise for this afternoon, there's a few unique things. It is linked on our web page, if you go there, you'll see a markdown file that describes the group exercise. Essentially, what I've proposed that you do is to break into small groups similar to those we made yesterday, and then identify a research question that you believe can be answered using some of the methods we discussed this morning. You're not going to actually do all the research. You're going to start to produce essentially a sampling frame for doing that research. You're going to do that by using some type of legal screen scraping of, you might, for example, if your study was about studying political debate online, your sample might be a list of senators like we were just looking at, and you might find a Wikipedia page that contains the Twitter handles of these elected officials, scrape those, then use those to make API calls to populate a sample, and then if you get there, think about the strengths and weaknesses of the data you've collected, and then outline a hybrid research design, maybe an app, maybe a bot that you could use to improve and address some of those limitations. And there's one unique thing also that I'd like to ask you to consider doing. So obviously you're not going to do all this. Most of it's going to be a programmatic. And remember, we're building towards group projects. So if you discover some synergy in your group, great, work with that. But there's one additional little thing here. Within each group, I'd like you to have a discussion about your skill in coding. And I'd like the person with the least experience coding to be behind the wheel, to be writing the code. And the goal here is to help ensure that that person doesn't fall behind as people are rapidly writing code, but those of you who are more experienced to teach people how to code. Okay? So we'll see you back here at 1:30. Okay, great. And